Hi everyone, today we'll be looking at the May 19 1H paper. So question 1, we're being asked to show that 4 2/3 minus 1 and the 9th divided by 1 and the 9th is 4 and the 5th. So we need to avoid using a calculator here. So we have 4 2/3 divided by 1 and the 9th. We're gonna turn this into improper fractions. So it's gonna be 14/3 divided by 10/9. Then we're just gonna go from division into multiplication by flipping the second fraction, 9/10. We've got some simplifications, the 3 with the 9 and the 14 with the 10. We get 21/5, which is of course 4 and the 5th as required. Question 2, we've got Jalina leaving her home at 10 o'clock to cycle to a park. On her way to the park, she stopped at a friend's house and then continued her journey to the park. And we've got the distance time graph for her journey to the park. So obviously this is the point where she stopped at the friend's house, and then she's at the park over here. On her journey to the park, did Jalina cycle at a faster speed before or after she stopped at her friend's house? Give a reason for your answer. Now we know that in distance time graphs, the gradient is the speed. So I will find the gradient of this straight line part and this straight line part here. Just by looking at it, this seems to be steeper, but we have to confirm this through calculation. So in the first hour, she covered a distance of 15 kilometers. So 15 kilometers per hour before stopping at the house. And then afterwards, if we look at the graph, well, from 11:15 up to 12 o'clock, that's 3/4 of an hour. She covered a distance of 9 kilometers. So it's gonna be 9 divided by 3/4. So 9 kilometers divided by 3/4 of an hour. This is giving us a result of 12 kilometers per hour, and that's for after stopping at her friend's house. Hence, Jalina cycled faster before stopping. At her friend's house. I know this will take more than a minute because it's only worth a mark, but it takes more than a minute to actually write all the blah blah here to explain what's happening. And then Jalina stayed at the park for 45 minutes and then cycled without stopping at a constant speed of 16 kilometers per hour from the park back to her home. We need to show this information on the distance time graph. Now, the stopping for 45 minutes is just gonna be a horizontal line. So for 45 minutes means that from 12 up to 12:45. So it's gonna be something like this. And then she was going back at a speed of 16 kilometers per hour. Now, if she's covering 16 kilometers in an hour, then 24 kilometers will take her an hour and a half to cover. So that means that from 12:45 we'll go to 1:45, go to 2:15. This is exactly the time at which she's back home. So we're just gonna join this with a straight line and that would be the completed distance time graph. In C, we need to work out Jalina's average cycling speed in kilometers per hour, excluding the times during which she was not cycling. We need to give an answer correct to 1 decimal place. So if we just revisit for last time, this distance time graph, we know that she left the home at 10 o'clock. She arrived at 2:15 back home, and she had 15 minutes of a break here, another 45 minutes of a break here. So it's a total of an hour not moving. Now from 10 to 14:15, it's 4 hours and 15 minutes, 4 hours and a quarter. If you take out that hour, it's gonna be 3 hours and 15 minutes. So the time is 3.25 hours. And then the distance she covered was the 24 kilometers to go and the 24 kilometers to come back, which is 48 kilometers. So the speed is just the distance over the time. And we need to give answers to 1 decimal place, which turns out to be 14.8 kilometers per hour. 3, we've got to simplify e to the 9 divided by e to the 5. Well, it's just e to the 4 because I'm subtracting the indices. And then y squared raised to the power of 8. We all know that raising a power to a power means that we need to multiply the indices together. So that's just y to the 16. Now in C, to expand and simplify, x plus 9x minus 2, it's just x squared minus 2x plus 9x minus 18, which is x squared plus 7x minus 18 after collecting like terms together. And then in D, we need to factorize fully. Let's consider the numbers first of all. The highest common factor of 16 and 20 is 4. Then I have a cp squared factoring out, and I'm left with 4c cubed plus 5p. So that should be the factorization of the given expression. So, moving on to the next question, it's question 4. We need to fill in the table of values. We could just use the table mode of our calculator to generate the whole table again, and we are finding values of 9, 3, -3, and -1 for 2 marks. And then we need to draw the graph here. So I'm just gonna mark the points to start off with. So -2, 9 is here. Then it's -1, 3, 0, -1, 1, -3, 2, -3, 3, -1, and 4, 3. It's a parabola, it's a smiley face. I will join this together with a smooth line. Should look something like this. So we're looking for something that's smooth, doesn't have to be perfect. So this is the curve here. And that was question 4. 5, we've got Becky, who has a various 6-sided dice. We've got the probabilities of getting 1, 2, 3, 4, 5, or 6. She's gonna throw the dice 200 times. And it says, work out an estimate for the number of times that the dice will land on an even number. Now, before we actually find this estimate, we need to calculate the value of x. We know that adding up all of the probabilities here should be 1. So this will lead to an equation in x. So 2x plus 0.18 plus 2x plus 3x plus 0.26 plus x is 1. So we've got a total of 2, 4, 7, 8x plus 0.44 is 1. So 8x is 0.56, which means that x must be 0.07. I could quickly update the sum of the probabilities here, and I'm just saying sum of the probabilities because if we're looking for the probability of landing on an even number, then we certainly are looking for 2, 4, and 6. So we know that 3x will be just 0.21 and x is 0.07. So the probability that the dice will fall on an even number is just 0.18 plus 0.21 plus 0.07, which is 0.46. And then we're just gonna do 0.46 times 200, which gives an answer of 92. That's the number of times we expect to get an even number out of a total of 200 throws. So 92 here. In 6, we've got a solid cuboid, we've got the dimensions here. We know that the density is 0.7 grams per cubic centimeters, and we need to work out the mass. Now we know that density is mass over volume. We've got the density. If we just calculate the volume, we might be able to find the mass. So the volume is just 12 times 8 times 5, which gives an answer of 480 cubic centimeters. So I'm just going to say that 0.7 is the mass over 480. So 0.7 times 480 is 336. So this has a mass of 336 grams. Number 7, we need to write 5.7 times 10 to the 6 as an ordinary number. We will consume one of the powers of 10 to make 5.7 into 57, and we fill in with 5 zeros to make it into an ordinary number. Whereas for 0.004, we know that the decimal point needs to move by 1, 2, 3 places, so it's 4 times 10 to the minus 3. Because I'm making the number bigger, I'm decreasing the power of 10. And then work out 2 times 10 to the 4 plus 3 times 10 to the 5 over 6.4 times 10 to the minus 2. I'm just going to plug in everything on the calculator here and hopefully get an answer straight away. So the calculator is giving an answer of 5 followed by 2, 4, 6 zeros. So this is just 5 times 10 to the 6, or it's okay to leave it like that because you haven't been asked to give your answer in a particular form. So it could be an ordinary number or standard form. 8, we've got someone buying a boat for 170,000. The value of the boat depreciates, so that means that it decreases by 8% per year. We need to work out the value on the 1st of January of 2019. So we started off from 2016, and 2017, 18, 19. We've got 1, 2, 3 years elapsing between the original buying of the boat up to the time of interest. So we have 170,000. Now each time that we depreciate by 8%, we are multiplying by 0.92 because that's the multiplying factor associated with a decrease of 8%. And because we want this to happen for 3 consecutive years, I'm just gonna raise that to the power of 3, which gives an answer of 132,376.96. Well, we've been asked to give answers to the nearest dollar, so it has to be 132,377. In question 9, we've got a right angle triangle here, measure 6 by 6, and we've got the semicircle as well with diameter AC. We need to work out the area of the shape. Well, we know that the triangle has an area of 6 times 6 over 2, which is 18. And then we could find AC by using Pythagoras. So AC will be 6 squared plus 6 squared square root. This is 6 root 2. That's the diameter, so the radius is 3 root 2. And therefore the area is the 18, which is the area of the triangle, plus pi r squared over 2. It's the area of the circle divided by 2. This is 18 plus 9 pi, which we need to give correct to one decimal place. It turns out to be 46.3 squared centimeters. In 10, we have here the value of a being 2 to the n times 3 times 5 to the m. And we need to write 8a as a product of powers of its prime factors. Well, 8a is 2 to the power of 3 times 2 to the power of n times 3 times 5 to the power of m. We know that multiplying with a common base means that we can add up the indices, so it's 2 to the 3 plus n times 3 times 5 to the m. So the answer here is 2 to the 3 plus m times 3 times 5 to the m. In 11, C is b minus a. We know that a is 6 to the nearest integer and b is 15 to the nearest 5. We need to work out the upper bound for C. Well, we start by considering the upper and lower bounds for a and b respectively. If a is 6 to the nearest integer, then we know that the a could be anything between 6.5 and 5.5, whereas b being 15 to the nearest 5 means that we can go plus minus 2.5. The fact that we are to the nearest 5, I'm going to do plus minus half of that. So it's 17.5 and 12.5. So the upper bound for C would simply be found by making b as large as possible and a as small as possible in order to maximize the difference. So I'm just going to take 17.5 minus 5.5, which is 12. That's the maximum difference of the two. So this is 12. In 12, we need to factorize 2x squared plus minus 7x plus 6, which can be split into two brackets. I have a 2x and an x. I need to make 6. I will put a 3 and a 2, and both of them have to be negative to give me the plus 6 and the minus 7x as the middle term. B, I need to solve 4m plus 9 over 3, 7 minus 2m. So I will start by cross multiplying. So 4m plus 9 is 3 bracket 7 minus 2m. I will expand the right hand side to give me 21 minus 6m, which leads to 10m being 12. So m is 12 over 10, which simplifies to 6 over 5. No need to give it as a decimal, no need to give it as a mixed number. An improper fraction is just fine. And then C, we need to write down the fourth root of y over y in the form of y to the power of b, where b is a fraction. Well, the fourth root of y is just y to the power of a quarter, and y is just y to the 1. And if you've got division with a common base, all you need to do is subtract the indices. So it's y to the 1 over 4 minus 1, which is y to the minus 3 over 4. Moving on to 13, we've got two groups here. Group C, we've got 6 girls and 8 boys, and Group D, it's 3 girls and 7 boys. So a total of 14 children in the first one and 10 in the second one. We're gonna pick a child at random from C and then a child at random from D. So we've got a 6 out of 14 chance of picking a girl from C, and an 8 out of 14 for a boy, and then it's 3 out of 10 and 7 out of 10. So we've just completed the tree diagram here. What's the probability that there are 2 boys in the team? Obviously, I need to follow this route here, which is gonna be 8 over 14 times 7 over 10, which simplifies out to 2 over 5. Remember that with 3 diagrams, we are multiplying together the probabilities of the branches through which we travel. Now, in part C, we are considering the possibility of picking a second team, and we are wondering what's the probability we'll end up with 2 boys in each of the 2 teams, which simply means I pick from C, I get a boy, I pick from D, I get a boy, I go back to C, I'm getting another boy and another boy from D. So if I just look at this scenario here, this is the boy-boy scenario, and I will start all over again. Now I have 13 children in C, 7 of which are boys, and 9 children in D, 6 of which are boys. So I need to go through this route 2 times. So I will be multiplying 8 over 14 times 7 over 10 times 7 over 13 times 6 over 9, and this is giving a result of 28 over 195. So I'm picking 4 children, all of them being boys. I have 4 probabilities to be multiplied together. 14 is a question on sets. The universal set is all the integers, positive integers less than 20. X is those elements of the universal set which are less than 12, and B goes from 7 inclusive up to 16, 16 not being included. Now, A intersection B means the elements that are common both to A and B. So it's certainly going to be 7, 8, 9, 10, and 11. 12 is not included because it's not a member of A. Now, C is a set such that it's a subset of A and has 3 elements. Now, being a subset of A means we live entirely within A. So I could actually draw a circle here to represent A. A has all the positive integers up to and including 11. And we know that all members of C are even numbers, so it could be 2, 4, 6, 8, or 10. We need to list the members of one possible set C. Just by the phrasing used here, one possible set, it means that we've got multiple answers that could qualify for the 1 mark here. I'm just gonna give 2, 4, 6, but you can pick any 3 even numbers from what we've highlighted here, and that will still be a correct answer. 15, we need to use algebra to show that the recurring decimal 0.254 recurring is 14 out of 55. Remember that the dots above 5 and 4 indicate the beginning and end of the repeating pattern. I will start off by saying let x be 0.2545454. This goes on forever. Now I will multiply by 10 to get the 2 out of the decimal part. The 2 does not form part of the repeating pattern. And then I want to get one full pattern on the left hand side of the decimal part. So I'm going to consider 1000x, which is 254.5454. What I have achieved here is that we've got the same decimal part, which means that upon subtraction on one from the other, we will be getting integers. So 1000x minus 10x is 990x is equal to 252. So x is 252 over 990, which simplifies out to 14 over 55 as required. In 16, we're being given the first 5 terms of an arithmetic sequence. Just by looking at the numbers, I know that the first term is 7 and the common difference is 3. we need to find the sum of the first 100 terms here. The Sn formula is actually given in the formula sheet. So S100 will be n over 2a plus n minus 1d. I will plug everything on the calculator here and I'm getting a result of 50,550. In 17, we've got similar shapes. It's A with a height of 24 centimeters and B with a height of 36 centimeters. I can immediately tell you that the scaling factor, what I'm multiplying by, is 1.5. So we know that the surface area will be affected by this scaling factor to the power of 2. So if A has an area of 960 square centimeters, what I'll be doing is multiplying this by 1.5 squared, and this is giving me a result of 2,160 square centimeters. Now base B has a volume of V, so we're looking at volumes here. So if I put the volume here, we know that the multiplying factor will be times 1.5 to the power of 3, and we know that it's B that has a volume of V cubic centimeters. So to go back, I will be dividing by 1.5 to the power of 3. So I need to do V divided by 1.5 to the power of 3, which is V divided by 27 over 8, which is V times 8 over 27, which is simply 8V over 27. That's an expression for the volume of A in terms of V, 8V over 27. 18, we've got a triangle here. It's not a right angle triangle. I can't be using Pythagoras or SOHCAHTOA. I'll be using the cosine rule. So PR squared is 17.8 squared plus 26.3 squared minus 2 times 17.8 times 26.3 cos of 36. I will plug everything on the calculator and take the square root. It's giving me a result of 15.8 correct to 3 SF. In question 19, we need to construct a histogram here for the heights of some trees. Now for a histogram, we need to know the frequency density. It depends on the frequency and the class width. The class width is just the difference between the class limits. So it's 20, 15, 5, and 10. So we've got frequency density just being the frequency over the class width, 15 over 20 is 0.75. 48 over 15 is 3.2. 21 over 5 is 4.2. 16 over 10 is 1.6. These will be the heights of the bars. So the first one, it will go up to 0.75. So it's gonna be something like this, up to 20. The next one goes up to 35 for a height of 3.2. So it's gonna be something like this. And then we go from 35 to 40 for a height of 4.2. So there it is. And then from 40 to 50 for a height of 1.6. This is where we start. So this is the histogram here. We need to work out BCD, and we need to give reasons here. I will actually start by drawing a straight line that will join B and D. This will allow me to use the alternate segment theorem because this here is 71 degrees. So I'm just gonna say that ABD is 71 degrees. The reason is alternate segment theorem. And then we have ADB, the angle here, should be also 71 degrees because angles at the base of an isosceles triangle are equal. So that's 71 degrees. And then this means that we can find angle BAD here. So BAD will simply be 180 minus 71 plus 71. Turns out to be 38. The reason is that we've got angles in a triangle adding up to 180 degrees. So angles in a triangle add up to 180 degrees. And then finally, now that we know that this angle here is 38 degrees, we can safely conclude that the angle BCD is 180 minus 38, which is 142. So BCD is 180 minus 38, which is 142, and the reason is opposite angles of a cyclic quadrilateral add up to 180 degrees. Now there were other ways of arriving at the answer of 142. One other way could have been once you establish that this is 71, then all of this is 142, and you can play again with alternate segment theorem and immediately get the 142. So there were many different ways of arriving at the correct answer. You need to be careful, however, to be providing reasons for every step along the way. 21, we've got a solid made from a hemisphere and a cylinder. So we've got the same radius, so this is R here. We are told that the height of the cylinder is essentially 3 times the radius. So the height here is actually 3R. The volume of the solid in total is 792 pi, and we need to work out the height of the solid. So we need to work out all of this, which is just 4R, because we've got 3R up to here, and then another radius over here. A total of 4R is the height we are after. Now, the total volume here is the volume of the hemisphere, so a half times 4 over 3 pi r cubed. Remember that the 4 over 3 pi r cubed is just the volume of a sphere, and then the volume of a cylinder is pi r squared h, and this is 792 pi. So I'm looking at 2 over 3 pi r cubed plus 3 pi r cubed is 792 pi. I will get rid of the fraction by multiplying everything by 3. So 2 pi r cubed plus 9 pi r cubed is 192 times 3 is 2376 pi. So 11 pi r cubed is 2376 pi. I will cancel out the pi and then divide by 11. I get r cubed is 216, and therefore r should be the third root of 216, which is 6. So the total height we're after was 4 radii, so it's 4 times 6, which is 24 centimeters. In 22, it's the graph of sine x drawn here, and we need to draw the graph of 2 sine x plus 30. We've got two transformations applied here. The 2 is stretching along the vertical by a scale factor of 2, which means all the y's get multiplied by 2. And the plus 30 means we've got a translation 30 degrees to the left. So I will actually start by doing the times 2, which means I will take the maximum to go at 2. So it's going to be something like this. And similarly on this side. So this is the graph of 2 sine x. And then the plus 30 will simply be a movement to the left by 30 degrees. Notice that each square is 30 degrees, so I'm just going to move everything by a square to the left. So it's going to be something like this. So I will actually copy and paste this and just move it a bit to the left. There it is. Let me change the color here. So let's make it blue, and we can get rid of the parts that we don't really need. So it's this part here, which is not part of the graph, and we need to continue this one here to go up to 1. So this is 2 sine of x plus 30. In B, we need to write down, it says x squared minus 6x plus 10 in the complete the square 4. So it's going to be x minus 3 squared. So it's going to be half of the coefficient of x minus 3 squared plus 10, which is x minus 3 squared plus 1. And then we need to describe fully the transformation that will take us from x squared into this curve. So if we start from f of x is x squared, then what we are looking at is f of x minus 3 plus 1. This is a translation 3 to the right and 1 up. So this is simply a translation by the vector. So translation by the vector 3, 1. 23, we've got a kite. A kite has 2 pairs of equal sides, so maybe something like this. So we've got AB and AD being equal in length, and we've got CB, CD being equal in length. B has coordinates 10, 19, and D has coordinates 2, 7. I'm asked to find the equation of AC, which is this line here. I will actually draw the diagonal from B to D, and we know that this should be a right angle and it should be passing through the midpoint of BD. So let's start. The midpoint of BD, I'm just gonna do the midpoint of the x's, so 10 plus 2 over 2, comma the midpoint of the y's, 19 plus 7 over 2, which is 6, comma 13. So we know that this straight line, for which we're trying to find the equation, passes through 6, 13. I could also find the gradient of BD, which is just gonna be y2 minus y1 over x2 minus x1, which is 12 over 8, so that's 3 over 2. Because there is a right angle here, we know that we can find the gradient of AC by flipping and changing the sign. So it's going to be minus 2/3. So we were after the equation of a straight line, say y equals mx plus c. What we know about this straight line is that m is a minus 2/3, so y is minus 2/3 x plus c. And we also know that when x is 6, y is 13. That will enable us to find c. So 13 is minus 2/3 of 6 plus c. So 13 is minus 4 plus c, leading to 17 being c. So the equation is y is minus 2/3 x plus 17. However, notice that I've been asked to give it in a particular form, collect the y and the x's on one side and the constant on the other, with all the coefficients being integers. So I will multiply everything by 3. 3y is minus 2x plus 51. So 3y plus 2x is 51, which is the correct answer in the correct form. 24, the last question of the paper. We are being given an expression for the displacement. We need to find the value of t for which the acceleration is 3 meters per square second. Now, from the displacement, we know that we can obtain an expression for velocity by differentiating. So v is ds dt. We get the power down, deduct 1 from the power. And actually, acceleration is the derivative of velocity with respect to time. So I will differentiate the second time, 6t minus 12. Now, we need to find the value of t for which a is 3. So I really need to solve 6t minus 12 is 3. 6t is 15. So t turns out to be 15/6, which simplifies to 5/2. That's the value of t, the time for which the acceleration will be 3 meters per square second. So that was this paper. Thank you very much.